Hi, everyone, and thanks for hosting us here. My name is Roman. I'm part of the SR Linux product management team at Nokia. And yeah, I will start with a disclaimer that we at Nokia, we unfortunately do not make unbreakable phones anymore. Instead, we are one of the leaders in the telecommunication industry, where we create hardware and software solutions for that power networks around the globe. And you know what's common between the smallest campus networks and the big service provider networks spanning continents is that they both use open source tooling through their network management operations. Now we see it even more than ever that open source tooling making its way to different angles of network operations, starting from the day zero tasks like design and implementation, through the configuration management and deployment, all the way to day two plus actions like alerting, monitoring, and so on and so forth. So open source tools are becoming quite important in the tool chain of a modern day network engineer. So today I will be joined by two of my colleagues, Karim and Erwan, and we will talk about the open source tools and projects we've built at Nokia for the network engineering community. I will kick off the session with a talk about Containerlab, the CLI tool that enables lab as code approach. We will talk about the rationale behind the tool, why we built it, what are the benefits that you might get while using it. And we will also run a small demo that demonstrates the Containerlab workflow, so you get a better feeling how to use it and how it was designed to be used. Next, Karim will take over the stage and he will talk about the GNMIC, gRPC Network Management Interface project that largely encompasses three sub-projects. So first of all, it's a simple and intuitive CLI tool that you can use to talk to GNMI-enabled devices. Next, it's a very powerful, highly available, and flexible streaming telemetry collector that you can deploy in your production networks and collect streaming telemetry from the fleet of your routers and switches. And it also offers the human-friendly API, so you can build automated solutions for network elements that speak GNMI back at you. We will wrap up with Erwan talking about not your usual AI application. The SR Linux GPT is, as the name suggests, offers some ChatGPT-like experience, but right in the CLI of SR Linux network operating system. So what sets it aside from a typical ChatGPT workflow that we all love and use is that it not only can answer basic questions about configuration, like how do I configure EVPN or how to configure VLANs on the interfaces, but it also knows how to extract data from the network operating system it runs on and answer questions like how many interfaces do I have up, or do I have any errors in my BGP peerings, and things like that. So it will extract the data from the NOS, augment the original question, and give you back a precise result. So with these three agenda items, I will kick off my part where I will talk about lab as code with Containerlab. And as the title says, we will basically focus on the three main components here. We will talk about the importance of labs. We will talk about why defining labs as code is really can get you some really nice benefits. And we will, of course, touch on the Containerlab tool itself that enables the lab as code approach. So the great thing about the NFD venue that we all have here is that we all have the background in network engineering, right? And we can approximately say the size of the fire hose we have been sipping from for the past number of years by getting better in the technologies that we as network engineers have to master. And the range of technologies keep growing. So we have to master not only classical routing protocols, but now we also have to deal with complex network management interfaces, IPAMs. Yang is knocking our door. So all these technologies are not really easy to master just by reading some blog posts or RFCs. You can't really say that you can operate a BGP network if you read a bunch of RFCs about it. You really have to build this muscle memory and hands-on experience, and then virtual labs come to the rescue. If you can spin up a virtual lab, like whenever you are on the go or at your home on any infrastructure that you have, you can really efficiently learn all of these technologies. So virtual labs for education and learning are really a key component to get you going to build this muscle memory and get proficient in a range of technologies that we as network engineers need to master. But also not only not only education and learning can benefit from virtual labs. If we take a look at the modern day networks, they start to embrace more frequent changes to be made to the network. And that is largely due to the pace that is increasing when we configure our networks. The pace is increasing and we introduce more changes to the network. Of course, it's in our nature to really introduce some errors when we do configuration tasks. Like no one is perfect. Even automated solutions can really introduce a big problem to your networks. That is why we want to have some network testing to be in place, or CI/CD as we know it, a colloquially term. And of course, we cannot test things in production network. Although we're all guilty of that, there's no shame in that, but it's not designed to be tested. Uh, you really do not want to test on the production network. You want to have virtual lab that kind of resembles the network that you're managing, but still it's a virtual thing that you can introduce breaking changes there, catch them early and fix them, and do not let your production network to go down because somebody fat fingered BGP command or shut down an interface that was supposed to be up. So now we all know that labs are important, and I provided a few examples why it is so. But then, why do we want to change the paradigm how we manage labs and introduce this as code angle? What are the benefits that we can get from it? And largely, the benefits come from the fact that when we define our lab as code, it becomes a source code. And the source code is meant to be checked to a Git repository nowadays. So the benefits that we get when we define our lab as code are really coming from the Git workflow benefits. For example, the collaboration angle is playing a huge part when you define something as code, because what you can do is that you can start building your lab, you can open a pull request on a version control system like GitHub, for example, and then you can invite over all your peers, colleagues from different departments even to collaborate and review the lab that you propose to spin up. And they can take a look at the protocols that you designed. Maybe they will alter the links that you proposed to this lab to have, because they might introduce some new concept that would be more tailored to the goal of the lab. And again, this collaboration effect can really help you build better labs and and have a better experience with labs as well. What we also have as a benefit from Labs as Code is the versioning angle. When you check in your code into a Git repository, you inherently have a linear history of all the changes. So you can say, I start my lab with a basic claw topology and I tag it as version 1. And as I iterate over and add more protocols or maybe more leaves and spines towards it, I can version my lab as version 2. And then I can easily compare the differences between my version 1 and version 2. I can swap the versions really easily. And that plays a big role when we talk about CI/CDs. For example, when you want to test version 1 of your network underlay and then switch to version 2 and see how your network reacts to that. And lastly, my probably favorite benefit from lab as code approach is that it's very easy to share labs. I'm a very community person. I like to share what I build. And when you do define your labs as code, there is no better way to share them than just publish them on GitHub. And then the rest of the world can easily pull your lab and experience the same workflow as you as lab designer basically baked into it. So these are the three interesting benefits that you can get when you define your labs as code. But also there is nothing that we are reinventing here. We are basically walking in the footsteps of giants ahead of us. Tools that you see on the slide are really infrastructure as code tools, where they basically lack a UI and they force you to use some domain-specific languages or YAML-based definitions of the infrastructure or software definitions. And this paradigm is really well known to a plethora of DevOps or SREs, and now network engineers get to enjoy the same experience. So what really Containerlab does is that it replaces the infrastructure as code tool in the networking domain. It allows you to define your lab as code, as a single YAML file where you define your links and nodes, and then it parses the file and deploys the lab on the infrastructure that you run it on. The interesting thing about Containerlab that the workflow that Containerlab offers differs from your usual workflow, for example, with the graphical UI solutions that deploy labs. In Containerlab, we follow the cattle mentality versus pet mentality. It means that you deploy your lab, you do your thing, and then you destroy it over. So the workflow looks like that. You take any Linux operating system, you install Docker and Containerlab, and then you get to write your topology definition file. Or you can just clone it from GitHub repository, or you can just copy it from some place where it is located. So once the Git CLab file is available to you, you can take Containerlab CLI tool and say, please deploy this lab over. Now deployment is finished and you get to interact with your lab nodes. You can connect to the SSH of your network operating systems. You can configure protocols. You can run some scripts that might be part of the lab. And once you are done, you can either save the state of your lab and check it back to a Git repository to save it persistently, or you can just destroy the lab entirely, for example, when you are doing some CI operations. And that means that you are really do not occupy a VM or a server with a lab solution. You just use the compute as you need to use it, and then you clean it all up so that somebody else can repurpose this VM for something else. So that's the difference between the traditional ways we run labs and the Containerlab workflow. Now, I wanted to make a stop here and talk about the Containerlab topology file, because that is really where things are happening. That's the way for you to define your lab, right? That's where code is located. So when we define a lab, we first start with a lab definition file and we give our lab a name. In my case, I give it a name NFD. And then we start to define nodes and links. So when you start to define nodes, you just give node a name. So in this case, I have a router1 name. And this is the freeform string. But what is not a freeform string is the kind. So what you see here is the kind VR Nokia SRS, which is one of the supported network operating systems in Containerlab. And you select a string from the Containerlab documentation side based on what network operating system you want this node to be to run. So that's your way to say, is it a Nokia SRS, or maybe it's a Juniper VMX, or maybe it's Arista COS. So that's your way to tell Containerlab which node you want to run. And lastly, but probably most important one, is the container image that Containerlab will use to spin this node from, right? That is the container image that you have to have on your machine, or you have to pull it from the internet if it's a public image. Next, you have to create some links. Well, you don't really have to, but most of the times you want your nodes to be connected, right? And the way to do that in Containerlab is really simple. You define your links section, which you see down below on the left-hand side, and you say, I want to connect my node SRL with its interface E11 to my node SRS with interface ETH1. So what Containerlab will do is that it will create a virtual link between two nodes, and it will use the interfaces that you declaratively defined in the topology definition file. The virtual link itself would be a virtual Ethernet pair, so it will pass all your layer 2 protocols like LECP and LLDP, so everything will flow just nicely. So when you bring nodes and links together, the topology kind of comes into the full shape. So you see that under 15 lines, we created a simple topology with just two nodes connected back to back together. And you can just copy paste this topology file and run it on your Linux machine. And granted you have the container images, you will be able to run this as is. So that is how simple it is. But now the interesting part is what kind of nodes can you run with Containerlab? Like in my demo, I just showed Nokia SRS and Nokia for Linux, but of course we are not just limited by Nokia software solutions here. Containerlab is an open source project, it's a community project. That is why we have a plethora of network operating systems supported. And first of all, because Containerlab works with containers, we focus on containerized network operating systems. So things like Nokia for Linux, Arista COS, and a bunch of others that you see on the slide are first-class citizens to Containerlab. These are native containerized network operating systems, which are typically sourced by the vendor. They are way faster to spin up compared to VMs. They have a smaller footprint, and it's really easy to share containerized images through container registry. What we realize is that vendors are now typically try to try to offer more natively containerized operating systems rather than VMs. And that is largely due to the fact that we need to run the network operating systems in cloud locations, like either in edge locations or in public clouds. That is why we do forecast that we will see more native containerized operating systems down the road. But not only network operating systems are welcome to the Containerlab party, we can leverage all the ecosystem of native Linux containers that community have built over the past couple of decades, and leverage all of them inside the Containerlab topology. So think of telemetry stacks with time series databases, flow collectors, your bird BGP daemons or Go BGP, anything that can be pulled from a container or created as a container can be natively supported by Containerlab. And that means that you can build topologies with really flexible and break out from the typical networking lab where you can add on top more applications around it. Because after all, network is just a pipe. We still want to run some services over it, and we want to make some use cases that demonstrate that. And lastly, we of course could not just turn a blind eye on the VMs, right? So we still want to run our Nokia SRSs, VMXs, IXRs, and they are VMs, right? So how do we run them in Containerlab? Well, we leverage another open source project, VRNetLab, that allows you to package a VM inside a Containerlab package, inside a container package. So from the Containerlab perspective, it squawks and ducks like a duck. So it's still a container. It's just that it happens that inside there is a camel process that runs your VM image, typically from a QCOW disk image. So that is why we can create topologies from native containerized operating systems and the old-fashioned VM-based packages as well. So that was like a quick intro to the Containerlab and what it is. But I think the best part would be to demonstrate how it all works, so you get a first-class experience with it and see how it all works together when we deploy a more like elaborated lab than just two nodes connected back to back together. So what I prepared for you is the SRL Linux telemetry lab. This is the lab that we've been running for quite a while now, and somebody might even be familiar with it. As you can see, it has a nice claw topology with 3 leaves, 2 spines, with 3 clients connected to the to push traffic. But what's quite cool here is that we run the full-blown telemetry stack on top with GNMIC telemetry collector, Prometheus to store our metrics, and Grafana to offer visualization. So this lab is not simple anymore, but it's still packaged in a simple GitHub repository that we will use here right now to showcase how easy it is to deploy a lab like that. So I mentioned that our labs are code now, right? What do we do with the code? We publish it to GitHub so that we can share it. That is exactly what we did with SRL Telemetry Lab. If you will go to github.com SRL Labs, SRL Telemetry Lab, you will get a repository that contains the code of this lab. You can go to the code button and copy the GitHub clone URL of this repository, then switch back to your terminal and say git clone and paste the URL of the repository. Now Git will clone the repository so you can check into the directory. And what you will see in the directory is the topology file that I mentioned. This topology file is way more complex than the one that we just saw before, right? Because it has a lot of things inside. We have our spines, we have our leaves, we have clients, which are configured with iperf commands to facilitate traffic push down the road. We have the telemetry stack with the relevant configuration. We have some startup configuration for the leaves and spines, so that when we deploy the lab, the nodes boot up and they start to form BGP adjacencies so that the traffic can flow through. So there's a lot of stuff happening here, but it's still all declaratively defined in a file. You don't have to click anywhere. You don't have to create links. It's all captured as a code artifact, and it's version controlled with Git. Now, when I say Containerlab deploy and I point my Containerlab to the file that we just looked at, Containerlab starts to pull every container image that is required for this lab to be running. If your images are published on GitHub, like Nokia SRL Linux, for example, it will be able to pull it from the internet And of course, the rest of the open source tools like Grafana, telemetry, Grafana, Prometheus, GNMIC, it's all public and open source software, so we can pull it from the internet. And once the Containerlab is done pulling, it will create the nodes and links between them, so it will form the topology. And lastly, it will show us a nice summary table with all the nodes it has deployed. So it says here, I deployed 14 nodes. We used these particular container images. My nodes are all running, and these are the IPv4 addresses on the management interfaces, which I can use to connect to the nodes. Now, as you remember, this lab was designed to showcase the streaming telemetry aspect of the networking, right? That is why we have Grafana node running in our lab. It's part of the lab topology. Containerlab just started it. And by default, Grafana exposes a web UI on port 3000. So if we point our browser to localhost 3000, we will have a UI of Grafana with a nice dashboard, which is as well part of the repository itself. So you do not need to build the topology. It's part of the lab that we built and we published publicly. You see that there's already some telemetry collected, like the number of IPv4 routes, some statistics about peers, some environmental stuff, the CPU utilization of the leaf that we're looking at, and so on and so forth. It's all already running because our nodes are started with a startup configuration that we reference in the topology repository itself. And the cool thing about it is that we do not really need to tell our user what to do here. It's all pre-packaged kind of canned solution to demonstrate the streaming telemetry workflow. And if a user wishes so, they can go and see how it all works. They can open up any panel of the Grafana dashboard and see how the Grafana query is made for the Prometheus database to extract data and all that good stuff. What we have inside this lab is a traffic script, because again, the repository is not just a bunch of network nodes. It's some scripts, some automation that you can package with your topology. And the traffic scripts instruct the clients to start iPerf client and server pairs. And once the iPerf has started, you will see that traffic starts to flow through the fabric. We see that the weather map on the right-hand side shows us nicely that there is ECMP happening from the leaves towards the two spines. We basically split our initial load to several flows, and they are load balanced. And on the left-hand side, we see that the DC traffic throughput panel shows us the spiking lines for the DC throughput measurements. It's all collected with streaming telemetry live, and users are able to interact with this dashboard and the telemetry stack just as easy. And as you remember, I also said that you, of course, can connect to the network node itself. You are not limited to just the dashboard of the Grafana or telemetry stack. You can just say SSH, username, and name of the node that we have in our topology, and you will be able to connect to the SSH shell. What I'm doing here is that I'm disabling Ethernet interface 149 on my leaf 1, because I just wanted to show that the telemetry stack reacts reactively to the changes that I made on my nodes. And as you can see, I just shut down port 49 on my leaf 1, and it turns red on the front panels of the switches, and it turns red on the weather map on the right-hand side. But most importantly, the traffic flow starts to rebalance using only spine 2 from client 3 side, and you see that the full flow goes to utilize only single link. That is why it turns a bit more reddish. So this is a nice way for anybody to try these labs. They are, as I said, canned solutions. They have a lot of stuff prepackaged inside. The cool thing about this particular lab is that it uses only public images and open source software. So if you clone this repository on your Linux machine, just like right now, you will be able to see exactly the same experience, and you will be able to run the same traffic script. You will see the same exact effect as you saw just on this screen capture. So now I wanted to switch gears and talk about the use cases that our user groups experience with Containerlab. And there are different user groups and different use cases and different benefits that these user groups experience from Containerlab. So for example, if you are a solo engineer, right, you are benefiting from Containerlab being lightweight, open, and free. So you don't have to pay for a hosted solution. You can deploy the labs on any infra that you have, just like an old server that you can spin up Linux OS there will do just fine. Install Docker, install Containerlab, and you will be able to leverage the labs that are available or you want to build yourself. By the way, you can build your lab portfolio if you're pursuing some expert level certifications. You can build the labs for each curriculum or each section of the book that you are going through, and you will be able to to use these labs down the road. If you are a network engineering team, things are a bit different. You want to leverage the collaborative angle of Containerlab. You want to build labs and invite teams to collaborate on them and share experience. Like in our case in Nokia, what we kind of do quite often is we build a lab topology and we ship it over to R&D because they develop solutions and they just need this network underlay. So they ask us as network engineers to develop the lab for a specific use case, and the software engineers use it on their infra to to create the network management systems or something that requires a network underlay. The network teams also leverage Containerlab in CI/CD fashion, and more people started to do so, which is a really great enhancement over the manual check of your network changes. So these are the different aspects of different use cases. And lastly, if you are a VAR, a partner, a vendor, or an education system, Containerlab is really an easy way to create the labs that you can share with your customers with this simplified workflow and infrastructure agnostic deployment. As you can see, as I just showed, a simple Git clone and Containerlab deploy gives you a fully working pre-canned lab that you can go over with your customers when you're sitting at the table, and you don't really need to carry over a server or occupy a VM with a lab software solution. And of course, you can collaborate with your customers and partners over the labs as well. So it's really comforting to see that community is picking up on Containerlab. With more than 100K installations, 80 contributors, a good number of supported operating systems, Containerlab is becoming de facto a standard tool to run container-based networking labs. And we wanted to thank all of our contributors, our users, for providing feedback and making the tool better. As I mentioned, this is an open source solution. We have a lot of vendors participated in the project and bringing over experience in their particular network operating systems. So I do hope that NFD delegates and NFD community will find this tool useful as well. And if you do so, please go to containerlab.dev website, which has a lot of documentation around the tool, a lot of examples with different vendors, different deployment scenarios, so you can get familiar with the tool way faster.
Roman, I have a question. This is Tim Bertino. I personally don't have any experience deploying containers. So when you create the topology file that lists out all the different devices you're going to use, as well as the different operating systems, does that then, when that gets run, does each device spin up its own container and there's networking between them? Okay, so it's not all devices running on one container, it splits them up and networks them. Okay.
Yeah, absolutely. So every node in the topology basically maps to its own container. So what you have, if you have like 6 nodes, you have 6 containers, and then the magic happens when Containerlab creates these virtual links between them, so that the topology is formed.
Okay, that makes sense. Thank you.